Hello, this video is about square matrices and some vocabularies. Square matrix is any matrix that has the same number of rows as columns. In a matrix, we have same number of rows as columns. Then we have square matrix like 2 by 2 matrix, 3 by 3 matrix, 4 by 4 matrix. And the main diagonal of square matrix is the diagonal from the upper left corner to the lower right corner. As in the figure, we have 2 by 2 square matrix from upper left corner to the lower right corner. We have the main diagonal. And the multiplicative identity matrix is any square matrix named with the letter I that has all the entries along the main diagonal equal to 1 and all the other entries equal to 0. This is 2 by 2 multiplicative identity matrix. The numbers on the main diagonal are all 1, the rest is 0. Here we have multiplicative identity matrix 3 by 3, and along the main diagonal all numbers are 1, all the others are, the rest is 0. So those kind of matrices are multiplicative identity matrix. So where do we use multiplicative identity matrix? It's like 1 in numbers. When you multiply a number by 1, it is the number itself. For example, 3 multiplied by 1 is 3. 4 multiplied by 1 is 4. It has no effect on multiplication. Similarly, in matrices, multiplicative identity matrix has no effect on multiplication. When you multiply a number by identity matrix, a matrix by identity matrix, it's the matrix itself, like 1. Let's say we have a matrix A. By multiplying A by identity matrix, the result is still A. Or multiplying identity matrix by A, result is still A. As you can see in the example, this is multiplicative identity matrix 2 by 2. This is a 2 by 2 square matrix. Multiply them by each other, either first A then I or first I and A, then the result won't change. It's still A, like number 1. And what about powers of square matrices? So, since powers means multiplying the number itself, then powers of matrices means multiplying the matrix by itself. So remember the rules for multiplying matrices. The number of columns in the first must be same as number of rows in the second. So when we have a square matrix, for example 2 by 2, we can multiply it by itself. We have 2 by 2 matrix, multiply the matrix A by itself, another 2 by 2, so we have inner dimensions same, number of columns in the first is same as number of rows in the second, so that means we can do this multiplication. So we can multiply square matrices by themselves. So we can take their powers. We can multiply them by themselves. For example, A squared. As in the numbers, squaring a number means multiplying it by itself. So squaring a matrix means multiplying the matrix by itself. So it's A multiplied by A. You know matrix A, this is 7, 3, negative 2, 0. So we have the same matrix here, 7, 3, negative 2, 0. So we can do this multiplication. We multiply rows of the first by columns of the second. So 7 by 7, 7 by 7 plus 3 by negative 2. For the second entry, first row of the first, second column of the second, 7 by 3 plus 3 by 0. For the third entry, we are done with the first row. For the second row of the first column of the second, negative 2 by 7, 0 by negative 2. And finally, second row, second column, negative 2 by 3 plus 0 by 0. And simplify it. This will be our product matrix. So we can cube them in this case, we take the result and multiply it by itself again. We can take the fourth power, fifth power, whatever power we want. We can raise it to any power that we want, since it's a square matrix. We can do the same for B. This is a square matrix. This is also a square matrix. We have 3 rows, 3 columns, 3 by 3. Yes, we can take the powers of this matrix. What about C? In C, we see 2 rows, 3 columns, 2 rows, 3 columns. You multiply 2 by 3 by 2 by 3. As you can see, inner dimensions are not same. Then we cannot do this multiplication. We can't multiply C by itself because C is not compatible for multiplying by itself. What about I? I is also square matrix. We can do this multiplication. We can multiply I by itself no matter how many times as we want. So taking powers of I, say I squared, I cubed, I to the fourth, they're all equal to each other. Since multiplying any matrix by I results in that matrix, multiplying I by itself also results in I itself. So we don't have to do the calculation. I to the power of any number is I itself.